So in this video, I thought I'd talk about something a little bit different other than math, although I do have a math problem in case you're interested, which I'll show you at the end. When you're in graduate school, sometimes you have the habit of eating a lot and not moving around, which is the case of me. So last year when I was preparing for my qualifiers, I believe it was springtime 2022, I had started to put on some weight, and I never knew what weight I got to. It wasn't that much, comparatively speaking, but it was way too much for me. I never stepped on a scale, but I think I was probably in the neighborhood of 210 pounds, which I should be closer to 170. That's probably a more healthy weight for me. And I noticed I just didn't feel very good being about 210. And when springtime was over and summer began and I knew I had to really buckle down on studying for quals, I decided to lose some weight that summer, and a couple other people wanted to get in on it, and I'm not sure exactly how it came to fruition, but a bunch of us decided that we were going to do a weight loss challenge. And the weight loss challenge was pretty beneficial. We stuck to it for 2 months straight. There was one cheat day that we all agreed on during that summer. So there was one cheat day and then 2 months of health and fitness. And we all collectively lost a good bit of weight. Like, we were all gotten a lot better shape. And I think I dropped maybe 20 pounds. I was about 190 when I took the qualifying exam. And then the other two that I did it with, one of them lost 20 pounds and the other one lost, I believe, in the neighborhood of 30, which is pretty impressive. So if you're interested in doing something like this, the reason I did it was mostly because, well, obviously, I want to be a healthier weight, but also I knew that I wanted to be in the best shape I could be when I took the test so that my performance was optimal. And I wasn't in the absolute best shape I could have been in, but I was in considerably better shape, and it helped me during the test, even though I ultimately failed it. And so basically I find myself in the exact same position I was last year, because in the fall of 22, I was still doing okay. I was in good shape. But then after Christmas, Christmas happened, and then January, February, March, April, May, springtime, that's when I usually start putting on the pounds. And so basically I'm in the exact same situation I was last year. So I'm probably sitting at maybe 215 even. Dare I say 220, even though I don't want to. It's kind of scary for me. I'd really like to get back down to 190. So this summer, I've decided to do the weight loss challenge again. So if you're interested in doing something like this, here's basically what we're doing. So there's only 3 rules. So the first rule is that you only eat healthy foods. So the way we write it is, eat only the foods you know you should. Can I spell? You should be eating. Eat only the foods you know you should be eating. Watch me as I struggle with basic English sentences. That's rule number 1. Rule number 2. Every day you have 1 hour of exercise. Your exercise can be anything of your choice. Walking, running, swimming, basketball if you're interested. And I understand that, 1 hour of running is not the same as 1 hour of walking. But really, it's just supposed to be like, get out there and move, because it's good for you to get some exercise. And then there's a penalty if you fail either of these 2 things. So the penalty is that if you go a day where you don't do the 1 hour exercise, or you eat something you shouldn't be eating, like a Reese's Cup, then there's a $100 penalty that goes into a pot. And then at the end of the month, the other people get to decide what to do with the money. Split it up or spend it on something. I don't know what it is. Last year we had that rule. So these were the only 2 rules from last year, plus the $100 penalty. And you know, we were all kind of scared of the $100 penalty, but it kind of helped keep us honest so that no one ended up failing last summer, so there was no money to split. And you'll find that after a week of doing this, it becomes so easy. The first week is the hardest. After that, you don't even notice it. And I should also probably mention that there was photographic evidence of the 1 hour exercise, so we had to take a picture and send it to each other. So I'll write with pictures. Okay, so everything here is the same as it was last summer, but there's one additional perk that some people seem to like. And it's basically a token system. So for each 1 hour, so I'll just write here tokens. I'm not going to write it out. I'm just going to explain what it is. So the way it works is that if you do your 1 hour of exercise every day, and then for each additional hour of exercise you do that day, you will get basically a token. And the way the token works is that it's worth 100 calories that you can spend on any food that you want. So, but it's only redeemable on Saturdays. So every Saturday that comes up, you take your tokens and you decide, okay, do I want to spend it on something, or do I want to hold on to them for next week, collect some more, and get something extra tasty? So, and I think I've capped it at 10 tokens. You can't spend more than 1,000 calories on stuff, because I feel like that kind of defeats the point. I mean, what are you going to do? Get to the end of the month and you have 30 tokens and you just spend 30,000 calories just the whole last day just blowing your whole diet? I don't know. Anyway, this is kind of a fun thing for us to do. It does, you know, put us in a good mood when you eat right and you exercise and you do get these little reward things. It does make you work harder for the tasty foods that you want to eat. And my goal is to hopefully get down to 190 by the time the test is upon us, which is, I think, more than doable. You know, I have basically 3 months, because I'm pretty sure we're going to take that test at the end of August. So anyway, that's the health and fitness part of graduate school, because there is the danger of letting yourself go in graduate school, because basically what I would do is I would come home, I would do math, I'd get extra hungry, so I'd basically prepare a smorgasbord of food, and then that would power me for like several hours until I got tired and went to bed. And unfortunately, I wasn't really exercising much, because I actually do like exercise, like weightlifting. I was a big weightlifter for a while. And by big weightlifter, I meant like 9 months. There was like a 9-month period there where I was going to the gym every day, eating tons of chicken. And I did put on some muscle, so it wasn't, all lost. But then you stop exercising, but the eating continues, which isn't very good. Okay, so there's that. And so now I promised you a math problem. So where does this math problem come from? I was meeting with my analysis instructor. A bunch of us were, not just me specifically. And we were under the impression that he was going to give us more problems to do that day, but the whole, the class ended and he didn't give us any problems. And I asked him, like, weren't you supposed to give us extra problems today? I know I sound like that guy's like, oh, teacher, you didn't assign homework. But, grad school, if you get homework problems to do and practice for the quals, that's Christmas Day. That's a treat. So I asked him, like, you were supposed to give us problems. So then he's like, yeah, I don't have any problems for you. But then he stood there and thought, he's like, actually, I do have one problem for you. And it's a bit unusual. So he gave us the problem. No one has solved it. We know the answer. It's not an unsolvable problem, or a problem that has yet to be unsolved. Or it has yet to be solved. I said that wrong. But it's a little bit weird, and I didn't write it down, but I think I remember the basics of it. So the idea of the problem is this. You have your XY coordinate plane. And you look at the lattice points. So these are coordinates that have integer pairs. Or integer, you know what I mean. I'll write a couple of them here. Speed this up. And then fill in the details here. You also have lattice points here. So a lattice point is any pair xy that's in Z cross Z. There. So you have these lattice points. So the idea is this. You pick any 4 lattice points and you draw a square, and it has to be a square. And then maybe somewhere else I have like a square here. That's not very good. Maybe I choose this square here. It's kind of small. And then maybe, you know, I pick an even bigger square that encases another square. So it's 4 by 4. You get the idea. You make in squares. So the idea is that if you sum up all the lattice points that are contained within the square. So let's say that we pick the 3 by 3 square here. So what I'm saying here is that for each lattice point that's in the square, you sum them all up. And I'm just now realizing I forgot to tell you something very important. Each lattice point has a number associated with it. So you can think of it as like a function that maps from the lattice point to some real number. And I can call fxy like, I don't know, a that's dependent upon xy. So each of these lattice points has a number associated with it. All right. And it's not so much, and you're not adding up the lattice point, sorry. You're adding up the number that's associated with the lattice point that appears in the square. Okay. So each of these 9 points that appears in this 3 by 3 square has a number associated with it, and you add up the 9 numbers. So that's what I'm saying here. So you add up those 9 numbers, and it's equal to 1. And you assume that this is true for any single square that you can draw. So if instead I chose this 1 by 1 square, and I add up these 4 numbers, these A's that are associated with these 4 dots, if I add them all up, I'll get 1. Does it have to be bounded above by 1, or is it always equal to 1? I think it was equal to 1. So no matter what square you choose, you have this property. Okay. So what is the problem? The problem is if instead of drawing a square, I draw a rectangle, and I do the same game where I add up all of the numbers that appear inside the rectangle. The problem is to show that this sum is bounded above by 4. So this is the problem. I believe I remembered this problem correctly. I'm trying to think if I forgot anything. So just to reiterate, you have lattice points in the xy plane. Each lattice point has a real number associated with it, which you can think of as a function. So each point has a number associated with it. And if you draw any square in the xy plane, and you sum up all the numbers that appear inside the square, I'm including the boundary, obviously, then that sum is equal to 1. That's the assumption. And the problem is, if instead of drawing a square, you drew a rectangle of any size that you want, if you sum up all the numbers that appear inside the rectangle, that sum is bounded above by 4. And he did tell me that the 4 is not tight, which means that there are better bounds for the sum. Better meaning smaller. But I don't think he knows what the best bound is. I'm not sure if anyone knows the best bound, and I'm not entirely sure where he got this problem from. He just showed it to us. So this is the problem. I'm halfway interested in sitting down and solving it. I say halfway because I'm not sure how long it will take me to do, and I'm not sure if it'll benefit me when I'm preparing for my quals, because quals have to come first. But if I have some free time, I may take a stab at it. So the only thing about this problem that I'm a bit shaky on is this here. I'm not sure if it was bounded above by 1 or is equal to 1. In either case, just make the adjustment if you're interested in trying it yourself. But I'm pretty sure it was equal to 1. It's just I'm thinking about it like, how would you choose these A's in such a way that it's always equal to 1? I guess it's possible, but, I'm not the best graduate student on planet Earth. I am merely a struggling grad student, hence the channel name. Okay, so I think that's all I really want to talk about today, so thank you.